Welcome back, guys. So this is question 2.1 of our book Electric Circuit by Nilsson. So from today we have been starting the exercise questions of this book. So let us first start by question 2.1. So the statement of this question is the interconnection of ideal sources in the circuit in figure 2.1 valid or not? Explain. Okay, so the first thing here is that whether these connections are valid or not. So these are all the independent sources. This is the independent voltage source, this is one, is also this one is the independent current source. Okay, so what is here and what should I consider for the validity of this? So the circuit will not be valid if it is like this one, the two voltage sources are connected, two or more voltage sources are connected in parallel in such a way that it has some voltage 15 volts and it has some voltage 16 volts or 20 volts. Somehow voltages are different in between both of them. Okay, so that these two connected are in parallel, and we know that in parallel the voltages will remain the same. So therefore this one is incorrect and it is not valid electric circuit. Okay, similarly another type of circuit is that if the two or more current sources are connected in series are not similar. Okay, so suppose this is the 5 amperes and this one is 10 amperes or somewhat different than this 5 amperes. So in this branch, in this series branch, we know that always the current remains the same. So therefore these type of circuits are also incorrect as well and are not valid circuits. Okay, so these two type of circuits if are not available, or if you can see any other combination just like these one, so you should keep in your mind that these connections are invalid. Okay, so looking at this circuit, there is nothing like this one. This is the voltage source, this is the voltage source, both of them are connected in series with each other, which is invalid. It doesn't satisfy this one, it doesn't satisfy this one, and this is a valid combination. Similarly, this current source is connected in series with these two voltage sources, and similarly this is the only current source here. So therefore the current through only this branch is 5 ampere. Okay, so therefore this one is the valid electric circuit. Okay, so that is the explanation for part A. Okay, so let me remove it. In part B of my question, identify which sources are developing power and which sources are absorbing power. Okay, so to discuss that which are these sources which absorb and which develop the current, let us first consider this current which is flowing in the clockwise direction. So here in considering this one, we can see that this is the current and here this current flows from positive to negative. Okay, so this one is leaving out from this terminal, and as this is the conventional or ideal circuit, so therefore we are considering the conventional current. So therefore when it will enter through positive and will come out of this negative terminal, so therefore this will be the absorbing source. Okay, so therefore let me write here V20 20 volts. This is what? This is the absorbing source. Okay, similarly here you can see that here the current is entering through negative and coming out of this positive. So therefore this is what? This is the developing power source. So therefore here we have V15 and that is the 15 volt source which is the delivering or developing power source. Okay, similarly here we can see that this is the current which is coming out of this one. So this is positive, this is negative for the current source. You should also keep in your mind that this should be the polarity here if nothing is given. So here again current is entering through this negative and coming out of this positive. So therefore this I 5 amperes is the 5 ampere and this is also the developing or delivering source. Okay, all of them are the sources. So these three are explained here. part C of it is verify that the total power developed in the circuits equal the total power absorbed. Okay, so let me solve it, and this is part C. So first let me find out all the absorbed power. Okay, so the only absorbed power is through this one, which is P20. Okay, so here this would be I20 multiplied by V20. Okay, which is what this V is the voltage across it, and I20 is the current which is flowing through all of this circuit. And we should keep in our mind that this is the series circuit, so therefore I20 is equal to the I15, which is equal to 5 amperes as given here in this branch. Okay, so the current through all of this is same, so therefore the I20 is 5. Okay, and the V20, which is already given here, is that is 20 volts, so therefore it is 100 watts. Okay, similarly the other one is the developed power. So let me write here about the developed power. So what is the developed power? So the total developed power is the power which is developed by this 15 volt source plus this 5 ampere source. Okay, so therefore the power developed by this 15 volt source is I15 multiplied by the V15 plus the power developed by this current source is I5 multiplied by the V5. Okay, so do we know this value? Yes, this is already known, and also from this formula as well. Do we know this value? Yes, this is already known from it as well, and that is 5 amperes. Okay, this is the I5. Do we know this value? Yes, V15 is known, and that is the 15 volts. But do we know this value? No, we don't know this one. So therefore, in order to find it out here, let me find it out here. Applying KVL through this loop, we will see that if this is the current, we will see that this is the 20 volts. Okay, minus 20 volts, and if this is the positive, so this is 15, and also this one is what the power through across it is V5, so this is equal to 0 according to the Kirchhoff's voltage law. Okay, so V5 here would be what? It would be the 5 volts as from this one. Okay, so let me write these values here as we have found it out. So let me write these values. This is 5 multiplied by 15 plus how much is this? This is 5 multiplied by 5. Okay, so it would be 75 plus 25, which is 5 multiplied by 5, so this one is 100 watt as well. Okay, so this one is equal to this one, so therefore both the power developed and the power absorbed are the similar ones. Okay, so this is what this is from part A to part C. So the part D of it is repeat A to C, reversing the polarity of the 20 volt source. Okay, so this is the 20 volt source, and reversing it we will get what? Let me reverse it. This is the first source, this is the second source. Okay, and the third source is here we have. Okay, the polarity of it remains the same. This is of 5 amperes, its polarity will remain the same. This is plus minus how much? That is 15 volts, and we have to reverse the polarity of this 20 volts, so this will remain the 20 volt, but the polarity of it would become this plus, this minus, while here we can see that it was negative and positive here. Okay, so now we have this circuit. Let us analyze it. First of all, is it the valid circuit? Okay, so this is a valid circuit because of the reasons we have described in our previous lecture, that there is none of the voltage source connected in parallel with the other voltage source, and also only a single current source which is in this loop. So therefore the value of current is known in this loop, and that is 5 amperes, okay, but we don't know the value of voltage across it. The part B is identify which sources are developing power and which sources are absorbing power. Okay, so let me have this current. Okay, so this is the current, and we can see that here it is moving from negative and coming out of this positive. So therefore this V20, this 20 volt is now what? This is the developing source. Okay, similarly here this is coming in from this negative and coming out of this positive. So therefore this V15 is also what? This one is the 15 volts, and this is what? This is also the developing one. In order to find it out, we don't know about this voltage, so let me have it. This is V5. We don't know about its polarity, so let me find it out by this one. So in this loop, applying the KVL, okay, applying KVL here, we know that V20 plus V15, because the polarity of both of them is now same, so therefore we are writing them, and plus V5. Suppose the polarity of it is unknown, so this is 0. So V5 is what? This is minus V20 plus V15. Okay, or writing the values of them, it would be 20 plus 15. So this V5 is how much? This is minus 35 volt. Okay, so minus 35 volts means the polarity of it is opposite of these polarities. So therefore writing them here, it will be what? It will be positive here and negative here. Okay, so therefore as the current here moving from positive and coming out of this negative, so therefore this V5, which is the I5 source, okay, and that is the 5 amperes, this is what? This is the absorbing source. Okay, so this is what? This is the absorbing, while the two ones here are the developing ones. The part C of it is verify that the total power developed in the circuit equals the total power absorbed. So the power developed here is the power which is developed by these two, and power which is absorbed by this source. Okay, so these are basically the developed power, and here this is the absorbing. So let me first find out the developed power. Okay, so the developed power, which is PD, that is the summation of the power by 20 volts and the 15 volts. Okay, this V20 is VI, so V20 and I20 plus V15 plus I15, and here it is understood that in this series circuit I20 is equal to the I15, and that is equal to I5 as well, and that is 5 amperes. Okay, you have to keep it in your mind. So let me put them here, the values. So this is 20 multiplied by this 5 plus V15 is 15 multiplied by 5, so it would be 100 plus 75, so it is 175 watt. Okay, so this is what? This is the power developed. Okay, now in order to find the absorbed power, let me find it out here. So absorbed power is the power which is absorbed by this 5 ampere source. So this is P5 and this is V5 multiplied by I5. So V5 is known, that was 35, as I'm just writing the magnitude of it, and I5 is how much? That is 5. Okay, so it would be, that is 175 watt as well. Okay, so we can see that here the developed power and the absorbed power are equivalent. So therefore we have solved part A to C for part D as well. Okay, so that's it for today, in which we have seen the validity of the circuit and solve it for different quantities ranging from voltage, current, and then to the powers as well. Okay, so that's it for today, and I will see you with some more interesting stuff in our upcoming video. See you soon. Welcome back, guys. So today we are going to solve two questions which are related to the validity of the electric circuits. So these are question 2.2 and 2.3, and both of them are basically relevant with each other. So let me first go through question 2.2. So the statement of this question is, if the interconnection in figure 2.2, okay, so this is the figure 2.2, is valid, find the total power developed in the circuit. If the interconnection is not valid, explain it. Okay, so here this is the circuit, and we can see that there is no reason to make it invalid. Okay, I have previously told you that a circuit will be invalid if two or more than two voltage sources are connected in parallel, which has the voltage values different from each other. So it means that the different parallel voltages are connected, which is inconsistent with the rules of the electric circuit. Okay, similarly, if you have a single loop and two or more than two current sources are connected in it in such a way that all of them has the different values, so that is also the invalid circuit. But there is no connection like that one which we can call the invalid, so this circuit is the valid electric circuit. Okay, so if this is the valid electric circuit, we have to find what? We have to find the total power developed. In order to find the total power developed, we have to see that what are the sources which are developing the power. So here we have this 50 volt source, 10 volt source, 40 volt source, and 5 ampere current source. All of them are basically the independent sources. Okay, so first of all, in order to find it out, let me find out the voltage across this. So let me call it V5. We don't know its polarity, so first of all, let me apply KVL here in this circuit. In order to apply the KVL, let me consider the direction of the current. So let me consider the direction of the current, and let me take it this one which is inconsistent with this current source. So if we have taken it, so let me use this voltage source here as well. So this is what, let me call it V40. Okay, V40, and here we can see that current is entering through negative and coming out of this source through this positive terminal. So I am taking it positive. Here we can see that current is entering through this positive terminal and coming out of this negative terminal, so therefore I am taking it negative. So minus V10 here again. So this is the anti-clockwise current, so this is entering through this positive, coming out of this negative, so I am taking it negative as well. So this is V50. Okay, so the last one here is 5, so I am taking it as it is because this one is the unknown. Okay, so this must be equal to 0. So all of these values are known except this V5. So in order to find this V5, we have here minus V40 minus V10 minus V50. Okay, so here we have, so let me put these values. So this is 40. Okay, this is negative 40 minus 10 minus 50. Okay, so this is what, this is 20 volts, positive 20 volts. So what is mean by this positive 20 volts? Positive 20 volts means that the polarity we have taken for this V5 is correct, and the polarity we have taken for this one was of similar as this V40, because both of them are the positive ones. So therefore this is now here negative and this one is positive. Okay, so this is the polarity of it. Now in order to see which are the developing and which are the absorbing sources, here according to this current, this source, because here the current is entering through negative and coming out of this positive, let me use this color, current is entering through this negative, coming out of this positive. Here again current is entering through this negative, coming out of this positive. positive according to this current direction. So these are this V5 and this V40, both of them are the developing sources. So in order to find the value of it, so PD is equal to what? PD is equal to the power developed across this 5 ampere source plus the power developed across this 40 volt source. Okay, so let me have the formula, and we know that P is equal to IV. Okay, here I is I5, okay, which is the current going through this source, and here this is V5. Similarly, here we have I40 and V40 as well. In this series circuit, we can clearly see that the current through all of these elements is the similar one, and that is the 5 ampere. So let me write here 5 multiplied by the value of V5, which I have already found out is this 20. Okay, and the value of I40 is again the similar one, which is this one, a constant overall through this branch. So this one is 5 multiplied by V40, this is 40. So let me find it out. This is 100 plus this is 200. Okay, so this is now 300 watts, which is the developed power through this circuit. Okay, so that is the solution of the question, because we are asked to find out the developed power and we have found out by this formula. Okay, so that is the solution of question 2.2. So now here in this question 2.3, let me solve it. So in solving this one, we can see that one current source is this one, and while the other current source is this one. So first of all, we have to see that whether this is a valid circuit or not. These two voltage sources are connected here, which is completely valid. These two, one current source, one voltage source, these are connected in parallel, which is also valid because no two or more than two different voltage sources are connected in parallel. So this is a valid circuit, and also there are no two or more than two current sources which are different in values are connected in series. So here we can see that this is a valid source. After it, we have to find what? We have to find this V10 and V5 as well to find out the power developed by this source and this source as well. So this V10, we can see that this is in parallel with this 100 volt source, so the polarity of it will be the similar one as that of this one, and the voltage across this one will be the similar one as that of this source. Okay, in order to find out the voltage across this V5, let me consider the current here. So this is the current here, and let me use the KVL here. So in order to find the KVL here, we have to do what? Here this will be, let me consider this one as the positive, so it will be negative positive. So let me consider this one as V5. Okay, this is now current is entering through positive, coming out of this negative, so this is minus 40. Okay, and also as the current is entering through this positive, coming out of this negative, so this one is minus 100 as well, and this is equal to 0. So in order to find this out, it is minus 140 equal to 0, and the value for V5, once we will find it out, this is 140 volts, and this is now known. Okay, so now in order to find the power developed by this 10 amps, this is what? This is, let me have P10, and this is the I multiplied by V10. So I10 is known, that is 10 amperes. V10 is also known, and we have already found it out, that is 100, which is 1000 watts. Okay, and the value of the power which this source 5 amp source is developing, let me call it P5. This is also I5 multiplied by V5. Do we know the value of I5? Because this is the current source, so that is already known. 5 amperes multiplied by V5, and that is 140. Okay, so here finding it out, what will we get? It will be 700 watts. Okay, so the total power developed here is PT is P10 plus P5 Okay, adding them together we will get 1700 watts, and that is the solution of our question. Okay, so that's it for today, in which we have seen the solution of question 2.3 and also the solution of question 2.2 as well. Okay, so these are the two solutions. If you have any question regarding these solutions, you can ask me in the comment box. See you soon. Welcome back, guys. So this is question 2.4 from the similar book of electric circuit by Nilsson, and the statement of this question is, if the interconnection in figure P2.4, this is the figure, is valid, find the total power developed by the voltage sources. Okay, here we have this voltage source and this voltage source as well. If the interconnection is not valid, explain why. Okay, so first of all, let me explain here that what is mean by the valid and invalid electric circuit. So in terms of the voltage sources, if we have a voltage source connected here, some other thing just like resistor or capacitor or some other element here, and another voltage source is here, and also one or two or many voltage sources are here which are also connected in parallel with them. So suppose this is VA, the value of it is VB. Okay, and there are many, and let me have here VC. Okay, plus minus plus minus plus minus. Okay, such that VA is not equal to VB. Okay, so in this case, if you have two or more than two sources here such that the voltages they have are different from each other, so this one is basically the invalid circuit. Why? Because of the reason that in parallel circuit voltage always remains the same. Okay, here the voltages will remain the same if this is point A, B, C, D. Okay, if these are connected in parallel, and what is meant by parallel? Parallel means that both the terminals of the elements are connected in similar point. Okay, if I want to redraw it, I can redraw it in this way as well. Okay, and if there are more than these sources, these are here. Okay, so here we can see that the connection points A and B here are similar, so these are in parallel with each other. So when these are in parallel, the voltages remain same in between them, but if these are not similar one, this source or this circuit is basically the invalid circuit. Another case is that if we have a series circuit, and in this series circuit I have two or more than two current sources. Okay, so let me have here, and these current sources are not equivalent in values. If this is IA, this is IB. Okay, and if IA is not equal to IB, this one is also the invalid circuit, because here according to the circuit analysis rules, the current in a branch of a series circuit will always remains the same. Okay, but here we can see that this is not the phenomena when this condition is satisfied. Okay, so keeping these two things in our mind, let us evaluate this circuit, and here we can see that if we have this loop and this loop as well, and we want to see that what are the conditions, whether this or this is met or not. So we can see that according to this first circuit, we can see here that none of the voltage sources are in parallel with each other. These two nodes are not connected directly with these two nodes, so therefore these are not in parallel with each other. Similarly, if we see here in this loop, the current remains the same, which is this 8 ampere, but here when we come to this loop, we can see that here this current is the only constant one, but in this branch the value of it is 4 ampere, while here this is 3 ampere, while this IA is constant throughout this loop. Therefore we can see that here in this loop there are two current sources, and 4A is not equal to 3A, so therefore this circuit is just like this one, and we can see that this is invalid circuit. Okay, so I have explained the reason that why is it not a valid circuit, and I hope you have understood the reason behind the invalidity of this circuit. So that's it for today. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 2.6, and the statement of this question is: consider the interconnection shown in figure P2.6. This is the series circuit which contains two independent sources. One of them is the independent current source, the other one is the independent voltage source, while this one is the current source which is dependent upon this V1. Okay, you can see that here this diamond shape source diagram, which basically shows that this is the dependent source, and this arrow sign shows that this is the current source. So therefore this one is the dependent current source, and the value of it basically describes that it is dependent upon this V1. What are the dependent current sources? These can be the transistors or many other devices which depends upon some other sources. We will go through it in our upcoming videos. So let us move to our question now. So in this circuit, what value of V1 is required to make this a valid interconnection? And B is, for this value of V1, find the power associated with the voltage source. Okay, so in this series circuit, we can see that this is a series circuit, and here we can see that here this current remains the same to make this and this equivalent. If this 400 milliamperes is flowing through this circuit, these two current sources should have the similar value. Means in this branch, as this one is the single branch in this circuit and this is a series circuit, and I have told you in our previous videos that to make a circuit valid, we must have all the current sources connected in a single branch should have a similar value. So therefore the value of it and this one, these should be the similar ones. So therefore 400 milliamps should be equal to what? It should be equal to V1 divided by 50, which are these two ones. Okay, so in order to make them equivalent, it is what? This is 0.4 actually, and this is V1 divided by 50. So the value of V1 should be equal to what? It should be 0 multiplied by 0.4. So this is what? This will be 20 volts. Okay, so this should be the value of V1 if we want to make this one a valid circuit. If the value of V1 is 20 volt, this will be a valid circuit. Okay, so that is what? That is basically the solution of part A of our question, where we have found the value of V1 for the validity of a circuit. In part B of our question, if we have found the value of V1 which is 20 volt, what should be the power associated with the voltage source? As we can see that the actual direction of the current is here, for which we have also found out the value of V as well. If this is the direction of the current, which is basically the actual direction, then the current enters through this positive one and comes out of this negative terminal. Okay, so what does it shows? It shows that this source is basically the absorbing source. Okay, so when this one is the absorbing source, V1 is the power absorbing source, not the developing source. These two are the developing sources. So the power associated with this one is, the well-known power formula is P is equal to IV. So the current through this one is the similar one which is flowing in this circuit, and that is given by this one, that is 400 milliamps or 0.4 amperes. Okay, similarly the V of it is also known, and that is 20, which is the voltage across it. So let me find it out. Finding it out, this will be 2. So this is 8 watt absorbing power. Okay, so that's it for today, in which we have discussed the dependent current source and also what are the requirements for making any circuit a valid electric circuit. So that's it for today, and I will see you with some more interesting stuff in our upcoming video. See you soon. Welcome back, guys. This is question 2.7, and the statement of this question is: consider the interconnection shown in figure P2.7. where this is the figure. Here let us first discuss this figure. This is a voltage source, or we can call it the independent voltage source. Similarly, this one is the current source, and this is called the independent current source because of this circular shapes. Okay, this is a circular shape, this one is also a circular shape, and the arrow here basically denotes the current source. Similarly, here this diamond shape basically represents the dependent source, and here the terminals of negative and positive shows that this is a voltage source. So therefore this one is the dependent voltage source. So over what it does depend, it depends upon this I delta. So therefore this one is the current controlled dependent voltage source, and this I delta is here. Okay, so this current basically controls this one, so it depends upon this current. So what are the examples? It exists in the real world. Yes, there are many examples, and one of those examples is the operation amplifier, which is the current controlled voltage source. Also bipolar junction transistors or many other transistors are basically the examples of these one. Okay, so there are many other dependent sources as well, and we will talk about them in our upcoming video when we will solve the questions related to them. So let us go through the statement of this question. So in this circuit, what are the different parts? So in part A, what value of alpha is required to make this a valid interconnection? So what is alpha? Alpha is the multiplicative term here with this I delta, and in order to find it out, we can see that in this circuit, if these two are basically the common nodes in between this voltage source and this one, so to make this a valid circuit, in the parallel ones the voltage across here should remain the same. Voltage here in between these terminals and these nodes should remain the same. So therefore let me solve it, and in solving it, minus alpha I delta should be equal to 6. Why minus? Because you can see that here this is positive negative, and here this is negative positive. We cannot change the terminals of it, but the dependency of it can be changed, and it can be changed by putting the negative with this one. Okay, do we know the value of I delta? Let us look at it here, and in this branch, let me use this color. In this branch we can very clearly see that this is I delta, and in this branch the current is constant, which is 15 milliamps, and we can see that the direction of this 15 milliamps is in opposite one as that of this I delta. So therefore the value of I delta is what? That is also minus 15 milliamps or minus 0.015 amps. If you know this value, let me put it here, and putting it here, it will be minus alpha minus 0.015 is equal to 6, or alpha is equal to this minus is plus 0.015 equal to 6, or alpha is equal to 6 divided by 0.015. Okay, solving it, what will we get? This will be 400. Okay, so the value of alpha to make this circuit a valid one should be kept at 400, otherwise this will be an invalid circuit. Okay, so this is the solution of part A. In part B, for this value of alpha, find the power associated with the current source. So this is the current source, and to find the power across it, we know the formula, that is P is equal to IV. Do we know the value of voltage? Yes, that is already known, and this is the similar voltage which is here. So if we have here VA, so it can be like this one, this one, and this one. This is the current source, this is the voltage source, while this one, sorry for my drawing here, this one is for this dependent voltage source. We can see that all of these three are basically in parallel with each other, having these two nodes common in between them. So these are basically parallel, so voltage will remain same across them. So therefore the voltage across it will be 6 volt as well. Okay, so the value of voltage is 6 and the current is 15 milliamps or 0.015 0.015, which is known by this branch current. So 0.015 multiplied by what? Multiplied by 6. So let me find it out. 15 multiplied by 6 divided by what? Divided by 1000. So this will be what? 90 divided by 1000. This will cancel out and it will be 0.09 watt. Okay, so this is what? This is for the power across it, or it can also be the 90 milliwatts. Okay, so this is the power across it. In part C, is the current source supplying or absorbing power? Okay, we don't know about that, whether this current source is supplying or absorbing the current. So in order to find it out, let me find out the polarity across it. So the constant polarity across it is due to this constant source, which is the independent source. So therefore this polarity will remain same here, and it will be plus minus here because of this polarity. This can be changed by choosing the negative value of alpha or I delta. So it is not constant, it is the dependent source. So the polarity of it will solidly depend upon this constant source. So therefore it will be plus minus. And also we can see that the actual current here basically enters, let me use this color, enters through this positive one and coming out of this negative terminal. So it shows the absorbing ability of this one. So therefore this current source is basically the absorbing source here. Okay, so it absorbs the power here. So that's it for today, in which we have solved question 2.7 of our book. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. So this is question 2.8 and 2.9. Today we are going to solve both of them, as both of them are closely relevant with each other. So let us go through question 2.8 first. So according to the statement of this question, is the interconnection in figure P2.8 valid or not? Explain. Okay, so this is P2.8 and we have to see that whether this is valid or not. And B is, can you find the total energy developed in this circuit? Okay, so this is the second part of it. So first of all, let us see that whether this one is valid or not. So this is the common point here. Here this is the voltage source, the current source, this one is the source as well, and these are the two sources here. So we can see that here the voltage is VA, which can be drawn just like here as well. Okay, this one is the dependent source, this is here, this is here, and we have it here. Okay, so this is the current source, the voltage source, the current source here as well, and the voltage source, and this is the current source, and this one is the dependent upon this I1, and therefore this one is the current dependent current source. Okay, so this is the dependent current source which depends upon this current. We can see that here these all are connected in parallel, and these are not the constant sources, and these can adjust their voltages according to the current flowing through them. Okay, so therefore in order to see that what are the voltages across them, so let me have here VA, let me have here VB, and let me have here VC. So if the circuit is valid, it means that VC is equal to what? VA with this 20 volts, and it is equal to VB with this 30 volt. Okay, but why did I not write this 30 volts and this 20 volt? Because we don't know the polarities of this VA and VB. So therefore in order to do so, let me have first current. Okay, so this is the supposed current and this is the second current here. Both of the currents should be equal in direction. Is the, if this one is in the clockwise direction, the other one should also be in the clockwise direction. Okay, so we can see here that this is negative, this is positive, and as the direction of this current and this current, these two are in opposite with each other. So therefore one current is flowing through it like this one, and the other one, from the other one, the actual direction is this one. So therefore the polarities of both of them will be opposite than each other. So therefore the polarity across this one will be what? It will be negative and positive, because this is positive negative, it will be negative positive. Okay, so therefore applying here the concept, and we want here the positive and here the negative because of these signs. So therefore this one will be the positive one, while this one will be the negative one. So this one minus this one, if you apply the KVL through this one, so it will be VA minus 20 volts. Okay, so this is through this branch. Similarly, in this branch we can see that what is the voltage here. This is the current which we have supposed, and here it will go through this positive, come out of this one. Similarly, the actual direction of current is also this one. Okay, so therefore the polarities of both of them will remain the same, because this should remain the positive, this should be negative because of this polarity, and here it will be what? It will be plus minus, because here it is also plus minus. So therefore applying KVL across this branch, what will we get? These two voltages will add with each other, so VB plus 30 volts. Okay, so here this shows that this one is the valid circuit. Okay, so this is the validity of circuit. Can you explain the total? Can you find the total energy developed in the circuit? Explain. So in order to find the total energy in this circuit, we must have the currents which are known. Okay, so this is the current, but the voltage across this source, the voltage across this source and this current, these are unknown. In order to find them out, we have to solve this equation, which can have many solutions as well. Okay, if we don't know the values of these voltages, it is not possible for us to find the total energies developed here. Okay, so that is the solution of the question which we were solving, and this was 2.8. Similarly, in question 2.9, the statement of this question is, if the interconnection in figure P2.9 is valid, find the total power developed in the circuit. If the interconnection is not valid, explain why. So first of all, we have to see that whether this interconnection is valid or not. So therefore this one is what? These three are this one, and this one. You can see, let me draw it here as well. So this is here, this one is here. Okay, so this is plus minus 40 volts. This is the current source here, this is the dependent source. Okay, and this one is the current dependent voltage source because of these polarities, current dependent voltage source, and this is the independent voltage source here as well. This is the 60 volts, and another voltage source which is connected here within these two branches here as well. So this is 30 volts. Okay, so the voltage must remain same between all of them, because if this is VA, so VA is 30 volts, because here across these two nodes the voltage is 30 volts. Okay, similarly here, in order to see that this is 1800 Ix, so 1800 Ix is here, and what is the value of Ix? As it is flowing through this branch, so therefore the value of Ix is 50 milliamps. Okay, or that is 0.05 amps. Okay, putting it here, okay, what will we get? The voltage across it, let me have it here. So the voltage across it, let me call it VA. So the value of VA would be 1800 multiplied by 50 multiplied by 10 to the power minus 3, because of this Ix which is here. So finding it out, it will be what? It will be 180 multiplied by 50 divided by 1000. So these two will cancel out here. 18.5 is 90 divided by 10, so this will be 9. So the voltage here is 9. So applying the KVL across this branch, let me use this one. So in this branch, if we apply the KVL, it will be what? It will be VA plus 60. The value of VA is known, that is 9 plus 60, which is 69, which is showing that the voltage VA here is what? This is 69 volts, which is in contrast different than the actual voltage which is here. Okay, so therefore the two different voltages are connected in parallel with each other, which is impossible. Okay, which is impossible for the validity of a circuit. So that's why this circuit is invalid circuit. So that's it for today, in which we have discussed two very complicated circuits and saw that how to find the polarities of different sources if the polarities are unknown, and also the validity of the circuits as well. Also we have seen the current dependent current source as it is given here, and the current dependent voltage source which is here as well. So that's it for today. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 2.10, and the statement of this question is find the total power developed in the circuit in figure P2.10 if V naught is equal to 5 volts. So this is figure P2.10, and here the value of V naught is given, that is here, and the value across it is 5 volts. Okay, so that is what, that is the voltage which will be here, here and here as well, because if we see all of these are basically the common ones, so therefore these are in parallel. Okay, so these three branches, this one, and this one, all of these are in parallel with each other, so therefore the voltage will remain same across them. So here, in order to find the values of the power developed across everyone, we have the formula, that is P is equal to IV, means I should know the value of the current which is flowing through that source and the voltage which has been developed across that source. Okay, so here we have different sources. Here this is the voltage source, the value of the voltage is known, while the current value which is in this branch only, that is known, and that is 9 volts. Okay, similarly here in this source which is the current source, the value of current is known while the value of the voltage is unknown. So let me call it here plus minus VB, and we have to find it out. Okay, here in this branch the value of the current is again known, and that is 6 ampere because of the availability of this current source, while the value across it is unknown. Okay, we have to find it out, and that is V of A. So what do we have to find out? Let me write it here. We had to find out V of B. Here VB, VA is also unknown, which is here, and the value of VG, which is unknown because the value of current is known while the value of VG is unknown, and also the value of V naught, that is already known. Okay, so let us first find out the values of VB, VA and VG. In order to find the value of VB, what do we have to do? We have to apply the KVL here in this branch. Okay, so we know the total voltage here, and that is 5 volts. Okay, in order to find out the value of the unknown voltage here, we have to apply here the KVL, Kirchhoff's voltage law. So here it will be what? It will be, let me write it here, it will be what? It will be VB plus 20, that is equal to 5. Okay, so in order to find it out, we will get here VB is equal to, this will be there, so it will be minus 15 volts. So therefore the answer of this VB is minus 15 volts. Okay, so that is known now. In order to find the value of this VA, which is here, we know that here in this source the value of V naught is equal to 10 VA. So V naught is equal to 10 VA. Okay, and the value of V naught is known, that is 5. This is 10 VA, sorry, this is VA, so that is VA, and from it we can very easily find the value of VA, that is 5 divided by 10, or that is 0.5 volts. Okay, so the value of this VA is also known, and that is 0.5 volts. Now to find out the value of this VG, again let me use the KVL here as well, and in this branch the KVL here would be what? Here this all is known, and that is 5 volts. Okay, because of around this branch which is here, and let me write these voltages. So VA is this positive, negative, so let me take it positive 1. Okay, and let me write this VG, that is minus VG. Okay, so let me write their values. So 5 is equal to VA, the value of VA is known, and that is 0.5 minus VG. To find the value of VG, we have here 0.5 minus 5, so it will be, the value of VG would be minus 4.5 volts. So therefore this is minus 4.5 volts. Okay, so these quantities are now known, we have found them out, and now we can very easily find out all the values or all the powers across them as well. Okay, let me now clean it. So now let us start it from this source, which is here 9 amperes. Okay, so let us start it from this one. Let me use this color here. So this is P9, and in order to find the value of the power here, the formula is this one, the value of current through it, which is 9 known, and the value of voltage, which is VB, so that is minus 15. Okay, so P is equal to IV here. So 9 multiplied by minus 15 is minus 35 watts. Okay, and this negative denotes what? It means that this current source basically develops the power of 135 watts. Similarly, this 20 volt source, so here the current through it is known, and that is 9, and the voltage across it is 20. So this is now what? This is 180 watts, and the sign associated with this one is positive. It means that this one is the absorbing source. Okay, now let us move here, and this 6 amperes, P6 is what? The current through is 6 multiplied by the voltage across it is 0.5. So this is 0.5, and that is 3 watts, and plus sign denotes that this is the absorbing source. Okay, now this VG, let me call it PG, and the current through it is known, that is 6. Okay, and the voltage across it is minus 4.5, which is already known. Okay, one thing you have to keep it in your mind here, that if this one is minus 4.5 and the value here is 0.5, okay, so if we apply here the KVL, we will see that the value of it here would become what? It will be minus 4. Okay, which is not possible because of this 5 volts. So in order to maintain it, because this will have to maintain the voltage of 5 volts here, it will, the actual value of the current will be in the opposite direction as that of here. So therefore it should be the negative one. So here the current here, the opposite one as that of here. So it will be what? It will be the 27 watt, and this positive sign denotes the absorbing nature of this source. Okay, so now all of these are known. In order to find the power associated with this source, what do we have to do? We know the value across it, that is 5 volts. We don't know the value of the current which is passing through it. So let me have here this current, let me call it I naught. It reaches this node and splits into two parts. Let me call it IA, or let me call it IB, and here IA. Okay, so according to the KCL here, I naught is equal to IA plus IB. Let me put their value. So the value of IA is 6, the value of IB is 9, so this is 15 amperes. Okay, so in order to find cross it, let me call it P naught. So P naught will be equal to 15, which is I multiplied with the voltage, which is 5 here. So it will be what? It will be the 75 watts. Okay, but here keep it in your mind that as this is the dependent source, so therefore the actual direction of the current should be inwards, not outwards. So therefore the current, if this is inward, so it will be minus 15, so it will be minus 75 watts, which is the developing power. Okay, so this is one method. Another method is that in this overall circuit, the value of the developed and the absorbed power should be equivalent. Therefore here let me use this color here, P9 plus P20 plus P6 plus PG and plus this P naught. this should be equal to 0. All of these values are known except this P naught. So let me put them here, minus 135 plus 180 plus this P6 is 3 plus 27 plus P naught, that is equal to 0. Or here, adding them all together, we will see that it will be 75 plus P naught equal to 0, which will ultimately give me P naught equal to minus 75 watts, which also shows the developing nature of this dependent source. Okay, so this is the developed power and this one is the developed power as well. If we add them together, the total power developed PD, and that would be P naught plus P9, so this will be minus 210 watts. Okay, because this P naught is minus 75 watts, this P9 is minus 135, so adding them together we will get minus 210, and that is basically the solution of the question which is asked. So that's it for today. If you have any question in your mind, please ask me in the comment box. See you soon. Welcome back, guys. So this is question 2.11 of section 2.3, and the statement of this question is, for the circuit shown in figure P2.11. so this is P2.11, and this is the figure where we have this independent current source, this resistor, and this is the polarity of the voltage here. Okay, so what do we have to do? In part A of it, we have to find V. Okay, so let us first find V from it. So this is part A, and to find out V, we know the Ohm's law. So according to it, V is equal to I into R. Okay, so here, in order to find the V, we need to find out the value of I and R. So the value of R, which is the only resistor here, so all the voltage will be consumed across it. So the value of R is known, the value of I is given by this current source. So therefore, let me write it. So 15 multiplied by 10 raised to power minus 3 for 15 milliamps multiplied by R. So that is 3 multiplied by 10 raised to power 3 because of this kilo. Okay, so these two will cancel out and ultimately we will get 45 volts. Okay, so this is the value of V in part A. Okay, so after it, we have to find the power absorbed by the resistors. This is part B. In order to find the power absorbed by the resistor, we have to use the formula, which is P is equal to I square into R. Okay, or there is another formula as well, and that is V square divided by R. Similarly, for the sources, as we have done in our previous questions, for the sources, the value of the P or the power is always I multiplied by V, which is the current through that source and the voltage provided by that source. Okay, so this is for the sources, while these are for the resistors. Okay, for the impedances, we will discuss them in our upcoming videos. Till now, let us concentrate over the resistors, as we have a resistor here. Okay, so you can take any of these formulas and it will give you the similar output. So let me take this formula, V square divided by R. So P of R is V square divided by R. So the voltage across it is known, and that is 45, as we have already found it out. 45 square divided by R, and R is 3 kilo ohm or 3000. Okay, so let me find it out. 45 square, this is 2025 divided by 3000, so that is 0.675. okay, so that is the answer, or we can also write it in terms of the milliwatt. So it would be 675 milliwatt. Okay, that is the solution of part B. In part C, it is given that reverse the direction of the current source and repeat part A and part B. So here this is the current source and we have to reverse it. Let me reverse it here. Okay, so let me redraw it. So this is the source, this is the resistor, okay, and the polarity should remain the same. This is V, this is 3 kilo ohm, while it is given that we have to change the direction of this current. So this is 15 milliamps. Okay, so therefore the value of current is now what? That is minus 15 milliamps because of this value. Okay, so by changing these values, all the previous values will be negative, as we will write here the value of I equal to minus, so it will become here V equal to minus 45 volts. Okay, what does it mean? It means that the polarity we have selected is this one, but the actual polarity which is given by this negative sign is opposite as that we have supposed here. Okay, so this is positive, but the actual polarity here is what? The actual polarity is plus minus, and that has been due to this opposite direction of the current source. Okay, so that is for this part of question. In part B, which we have to do again, let me use the similar, as the values of the voltages are now here. So negative minus 45 square will be the similar one as this is, and the value of power will remain the same because of the value here, and the value of power will remain 675 milliwatt. Okay, the value of the power will remain the same. So that's it for today, in which we have seen a very basic circuit and analyze it by using the Ohm's law and the formula for the power for the resistors, okay, and for the sources as well. Okay, so if you have any question, you can ask me in the comment box. See you soon.